Hello, friends. Here's a video going over the questions we did in class regarding components and vectors. So here is the sheet, the worksheet we did. I'll also pull up the other one. And I'm going to go over a few key examples, specifically question 3, doing the components, and then again, these questions doing the components, and then the word question. The rest of them are important, but not as directly important for what the homework is. So this is for if you're stuck on the homework and you want to know what to do, here's what you do. I've written it out here. You separate V1 and delta V into their X and Y components, and then add them separately. Your table will help you. Don't forget to put them tail to head. And when you put them tail to head, you can then draw V2, starting at the beginning of the first and ending at the end of the second, such that in this example, V1 goes this way, delta V is tail to head, we're good. And then I can annotate, that's pretty cool, where I have V2 go from the beginning of V1 to the end of delta V. So the point is the initial velocity was this way, this was the change, and that turned it to the right. It also made it bigger. So this is a speeding up and turning. How do I know it's speeding up? It got bigger. How do I know it turned? Well, it turned to the right. If I'm going this way, right, up, if I'm going this way, and if you imagine you're in a kind of car going this way, right, you turn to the right. So this was up and right, and now it's just rightward. That's what you're veering right? You've removed the up. And that's exactly what we're going to see is happening with the components, speeding up and turning. Now, to do the math, we draw the components. And I'm going to draw V1's component first, where we have Vx and Vy, where Vx of V1 is 5 cosine 45. So Vx here is 5 cosine 45 degrees, which is about 3.5 or 3.53. And the y component is also the same because it's 5 sine 45, which is also the same as cosine 45 because it's a 45, 45, 90 triangle. But either way, you can just plug that in and you get 3.53. Now we need to establish positive and negative directions. So let's say positive is up and right is up. Oh, sorry, right is positive. Positive is up and positive is right. So that means these both are positive. And if we do delta V, I'll do it in a different color. We see that it's down and right. So remember, components, you're literally just saying the words. So what direction is this? Up and right. So you draw the up, you draw the right, you separate. This is down and right. So you draw the down, you draw the right. So this one, Vx and Vy for delta V, is going to be the same. So for delta V, Vx is 5 cosine 45, and Vy is 5 sine 45, but since it's down, it's negative. So remember, the positive and negative comes from whether it's up, down, left, or right. That's a direction. Remember, negative and positive for vectors are direction, right? So that's the whole point. So positive is up, positive is right. So this is positive, positive, but for delta V, it's going to be hold on, that's to the right for X, so that's 3.53 positive and negative 3.53. So notice in the picture, the up cancels the down, so you get 0. So notice the numbers should correspond what's happening in the picture. That's the whole point, right? And indeed, we get that it's only to the right at positive 7.06, or if we actually did it appropriately, you should get 7.07 just fine. Even if you rounded to 3.5, you get 7 just as good. So notice that this is the ultimate answer, and V2 therefore equals 7 0.06 or just 7 to the right. We don't need to do a Pythagorean theorem here. Or as I say, use the Pythagorean theorem to find the magnitude of V2. Well, Vy is 0, so we don't need to do that. In our practice part 2, we will. And I'll obviously guide us through that. But that's number 1. There it is. I wonder if I can take a screenshot of this. Not really sure if I can. Oh, I just did, because I need to clear it. There we go. Let's move on to number 2. So number 2 works like this. Samesies, only if I want to actually compare these, I need to draw this. Oopsies. I need to compare these tail to head like that, which means this is down and to the right. I need to actually draw this down and to the right, our delta V. I need to literally move it. So here it is. I can move its tail here, move its head here. As long as it's at the same angle, downward at 60 degrees, I can move it anywhere I want, and it's the same vector, which means my V2 goes from the tail of the first to the head of the second, and V2 looks like that. So once again, we should get that Vy is 0. I'm predicting that should be 0. So indeed, if you want to do this without drawing it like that, that's totally cool. In fact, I'll erase it. And we'll just start over just by drawing the components. So V1, the component is Vx, and the component is Vy. Vx is 20 cosine 60, which is 10. And we'll call that positive because positive is up and right. That's great. And Vy is 20 sine 60. And the sine of 60 is root 3 over 2, which is 0.866. So you should get something like, hold on, I'm going to do my calculator. I should have had the numbers prepared, but I didn't. So 20 times the sine of 60 gives me 17.32. And that's positive. So now for delta V, we do the same thing, rightward and downward. So you can say the words, all right? Really good tip. Up and right, so I have an up and a right. Down and right, so I have a down and a right. When you move the vector, that can't change. That doesn't change. So it's still down and right, even if I moved it there. But the point is, for delta V, I have Vx equaling 20 cos 60, which is positive 10. And I have Vy equaling downward, so it's negative 20 sine 60. So I'm saying the words, this is because it's down. Right? And this is because it's up. Right? So here we get negative 17.32, and behold, we get that that's 0, and this is positive 20. So our V2 indeed, once again, just like the other ones, maybe coincidence, I didn't mean to do that, is 20 to the right, where here positive means to the right. And 20 what? Well, it's a speed, so this one is meters per second. So this object was going up and right, and then this delta V canceled the up and made it go farther right. So once again, this is speeding up because its speed got faster. Oh, actually, it stayed the same speed. So this is just a turn. That's kind of fun. I didn't expect that. But we compare 20 to 20. Did its speed change? No. But did it turn? Yeah, it turned. That's kind of cool. Did you see how I kind of thought through that? Turning. Where I had an instinct, I'm like, well, it's got to speed up just like the other one, but it actually didn't. This one is just a right turn. Where it went from up and right just to the right, that's a right turn. Right, so this one's turning. That's it. So let's do number 2. You might see I added one here, but I actually want to go to the other page, which is this. So here we go. Hold on. Let me take a picture, save it. Great. Clear it. Great. Number 2. How do we do one where they don't cancel? Well, here I'm going to draw the components of V1 and the components of delta V just as I did before. If I want to, I can make sure they're tailed ahead and draw V2 from the tail of the first to the head of the second, like that. V2 therefore should be up and right. Great. Let's make positive up and positive right. You can choose something different, but I'm going to choose that. So V1 is positive 10, where Vx of V1 is 0. Stop and see if that makes sense, that it's only upward, and Vy is positive 10. Because it's only up, it's not at an angle, or you can say the angle is 90 degrees, right? It's straight up. Great, that's easier, right? We don't have to do components. The components are already there for us. So let me erase that. The components of delta V will be what? Say the words, right and down. So I draw the right and I draw the down. Vx is 8, because I see that's 8, cosine 45. And delta V, Vy is going to be 8. Careful, is that down? It is. There we are. So it's negative 8 sine 45, and it's negative because it's down. There we go. So delta V is going to be 8 times the sine of 45. Sine of 45 is 0.707, but you can just plug that into your calculator, and I get 5.66 or 5.65. So I'm going to write it as, careful, this is 8 cosine 45, which is also 5.66. That's positive. I always pause. So you notice I'll still pause, right? Pause, wait a minute. That's positive because it's right. Take that breath. Breathe in, breathe out, settle into your body. Positive 8 to the right. Got it. 0 plus 5.66 is plus 5.66. And then y, that's negative 5.66. Again, you can take a breath. That's down. That's negative, right? Down is negative 5.66. You can sit there and confirm that for a moment. So you'll notice that when we do 10 minus 5.66, you get 4.34, positive 4.34, which means this is, I will write the words, positive x is right. Positive 4.34 is up. Is V2 up and right? Dun, dun, dun. If this is 10 and this is 5.65 or negative 5.65, this component will be positive 4.34 up. And this component will be positive 5.66. Sorry for not making them dashed. And this is meters per second. So what is the angle? Let's do this angle. Up and right. And what is the actual value of V2? So it says draw it to V2 and its components. Great. I just did that. I'm going to draw it again. 4.34 and 5.66. Great. So I do V2 squared equals 4.34 squared plus 5.66 squared. So V2 is what? Well, 4.34 squared plus 5.66 squared, and then we square root it. I'm going to do that on my calculator. Ready? Clear? 4.34 times 4.34 equals plus 5.66 times 5.66 equals, and I get 50.87. So it's the square root of 50.87. Now you can do a fun pause and say, what's the square root of 50.87? Well, I know the square root of 49 is about 7. So this is going to be a little bit over 7. So this is going to be V2 is 7 point something. So I'm going to take the square root of 50.87, 7.13. There we are. Pause and make sure that number makes sense. It started at 10. I went 8 down and right. So this is a turning and slowing down. turning right, slowing down. And theta is the inverse tangent of opposite, which is the y, 4.34, over the x, 5.66, which is inverse tangent of 4.34 divided by 5.66 gives me 37.48 degrees. That's it. Save it. Hope that makes sense. That's about as hard as it's going to get. But if you do it step by step, I hope it should follow. So don't try to do it all at once. Follow the procedure. That's actually what I'm looking for, is how you follow the procedure and where it might break down. So you're splitting these up into components, adding them, redrawing it, and using the Pythagorean theorem to find the total, and then inverse tangent to find the angle. All you have to do is keep track of positive and negative. And if you want, you can draw V2 to confirm up and right. It's that straightforward. You don't want to overthink it. This is up, no right or left. This is right and down. This one's right and up, and split it up into the components of right and up. Pythagorean theorem gets you the total, inverse tangent gets you the angle. Just repeating it over and over again, because that's all that it is. Clear it? I'm going to do the last one. Here we go. We're doing it. So I actually realized this one we're going to do in class. So I'll leave that one be for time on the video. I want to go to this one. A rocket in space initially moving at 6 meters to the right and 8 meters per second upward. So how do we draw that? Well, I draw the right. (6 meters per second), and I draw the up, 8 meters per second. That's Vy, that's Vx. So I can get the angle by doing the inverse tangent if I want. I can get the total by doing Pythagorean theorem, and I get the square root of 8 squared plus 6 squared, which is 10. This is a 6, 8, 10 triangle. That's pretty cool. So that's the initial. So notice those key words. Maybe practice underlining them. Initial means V1. So that's V1. Awesome. So it's initially moving 10 meters per second up and right. Great. Fires its rockets, causing it to experience an acceleration, which I'll draw in red, downward of 2 meters per second per second. You can write it like that or write it like that. So that means the downward component's changing. So I'm actually going to skip to this. Describe what is qualitatively happening to the vertical component. It changes by 2 every second. Downward. Which means it decreases, right? So it changes by 2 every second downward until it gets to 0, and then it'll increase downward. So I drew the initial velocity in its components here. And qualitatively, what's happening to the vertical component is that it changes by 2 every second. So I'm drawing it like this. If I just draw the vertical, I get 8 up, and I get the acceleration is down. Do you remember these drawings? Right? So what's going to happen? Right? I have a velocity of 8 upward, and acceleration is downward. That's going to slow the object down by 2 every second. So this is the same thing that is what we did, only we're isolating the vertical. The horizontal is also happening. So what is happening to the horizontal? Is there any component to the acceleration that points left? No. Is there any component that points right? No, this is only vertical. That's a big deal. Pause and hopefully that makes sense. Because it's only vertical, that means the horizontal component is constant. If the change, which is acceleration is change in velocity. If the change is only pointing down, that means it's not pointing left or right. which means the left and right doesn't change, right? There's no leftward component of change. There's no rightward component of change. The change is down, which means only the up is going to then decrease and then go down. But Vx is constant. Let's look at that. So I hope that makes sense. And that's that one. So how many seconds does it take for the rocket's motion to become perfectly horizontal? Well, Vx is constant, which means that the horizontal velocity will always be 6. And the vertical, which is 8, decreases by 2 every second. So you can almost do that one in your head. So I'm going to call that negative. So positive is up and positive is right, which means that the time for this vertical component, so to become perfectly horizontal, how do you translate that? That means Vy is 0. Pause. Those words, which we'll use eventually over and over again, translates to this. Vy is 0. So if Vy is 0, that's the final. 0 equals the initial 8 plus acceleration times time. I'm using this one for the y direction. Right, so I'm using V2 equals V1 plus AT for the y direction. Right, so 0 equals 8 minus 2t, so t is 4 seconds. After 4 seconds, in fact, we could draw it as, right, at t equals 0, it's 6 and 8. At t equals 1, what happens? This one decreases by 2, it's 6 and 6. At t equals 2, it's 6 and 4. At t equals 3, it's 6 and 2. And at t equals 4, it's 6 and 0. So it's only horizontal. So notice we're isolating the vertical, and we can use our equations just in the vertical realm. That's where we want to shift to do it. I hope that made sense. Please, 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 please email me if you're doing your homework, if you have a question, whatever it is. Even if it's like, I'm stuck on number 2, cool. I'm going to ask you a question in return on, well, what are you stuck on? And therefore we get to establish a dialogue. And I promise you, everybody who's done it in the past has been so helped by just a few sentences of email. Please access me, right? So hopefully this video helped. And if you still have lingering questions, please, please, please email me. It's a joy to work with all of you. I will see you in class. Thank you so much.